Hi, everyone, and welcome back. It's Kira Garfoldo with Greenville Tech, and today we're going to talk about section 4.2 for Math 109, combining functions and composite functions. So basically, this whole section is about operations with different functions. There's several ways to combine functions that'll give you new functions. We can add functions to get a sum. We can subtract functions to get a difference. We can multiply functions to get a product. We can divide functions to get a quotient. And finally, we are going to talk about something new called the composition of functions. A lot of this is fairly simple, which is a nice refreshing break from the last couple of sections. I think you'll agree with that. So first, let's start with something easy, sums of functions. So if we have the notation of f plus g of x, all we are doing is adding f of x plus g of x. So for example, if we let f of x be x squared and g of x be the absolute value of x, then f plus g of x is simply x squared plus the absolute value of x. We add this piece to this piece, and voila. Similarly, we can find differences of functions. The notation here is f minus g of x. If we're finding f minus g of x, we're going to take f of x and we're going to subtract g of x. Very similar to what we did for the sum. So with our similar example from before, we have f of x equals x squared and g of x equals the absolute value of x. Then f minus g of x would simply be that x squared minus that absolute value of x. Pretty simple so far, right? Now we can also take products of functions. So to get a product of a function, we say f times g of x, and you guessed it, we're going to take f of x and we're going to multiply it by g of x. Now here things can get a little bit more complicated, so make sure that you're paying close attention, because remember, you may have to FOIL something, you may have to distribute something. You just want to be real careful with your algebra here. So from our earlier example, if we have f times g of x, we'll just have x squared times the absolute value of x. That could be simplified a little further, but we're going to leave it there for now. And lastly, we can have quotients of functions. To get a quotient of a function, you're going to have f divided by g of x. And probably like you guessed, you're going to divide f of x by g of x. So using our trusty example that we've already seen, where f of x is x squared and g of x is the absolute value of x, you're just going to put f of x over g of x to get x squared divided by the absolute value of x. Again, that could probably be simplified a little bit more, but that's not the highlight of our topic today. So take a few moments and digest. Hopefully that's one of the simpler things we've done so far. Let's look at another example. Suppose g of x is x squared plus 1 and h of x is x squared minus 1. I want you to pause your video, take a moment to find g plus h of x. When you're ready, you can go forward and see the solution. So to find g plus h of x, we're going to add g of x plus h of x, which is just going to simplify out to be 2x squared, because that plus 1 and that minus 1 are going to cancel. Let's look at the same example for a difference. Pause your video for a moment and try to solve it yourself. If you want to find the solution, you're going to find g of x minus h of x. So now those x squareds are what canceled, and we get a plus 1 minus a negative 1, and we end up with the final answer of 2. If you didn't get this answer, make sure that you check your algebra and your signs carefully. Negatives seem to be a big problem for a lot of people here. Let's do another example with a product. Again, pause your computer and move on when you're ready to see the solution. To solve this one, you have to be real careful. Make sure that you FOIL it out very carefully and then combine like terms. That x squared and that minus x squared, it's kind of a difference of squares, if you notice that. Those are going to cancel out. So all you're going to be left with is x to the 4th minus 1. And lastly, take a moment and pause to find the quotient. Here, you're just going to put g of x over h of x. And we're not going to simplify this any further. We're just going to leave it as x squared plus 1 over x squared minus 1. If you had any trouble with any of those, I would be willing to bet it was something with simple algebra, possibly foiling, possibly distributing, and possibly negatives. Remember, those negatives distribute as well. So take a moment and go back and be sure that you can get those answers, because you will see questions like this again. Okay, let's do a real world application. Suppose a light bulb manufacturer has two costs associated with making light bulbs, and we're going to let X be the number of bulbs sold. So this is a really common situation. We hit on it in last unit also. A lot of times if you're making something, you have those overhead fixed costs, and you also have costs to make each unit. So here our fixed costs are $4,000, and the variable costs are 2X. So for every light bulb you make, it costs you an additional $2. We're also going to note the number sold as N of X, which is just X. So how many are we selling? So first we want to define C of X to represent the total cost of making X bulbs. So remember that the total cost is going to be our fixed costs plus our variable costs. So we're just going to have F plus V of X, which is really just going to be adding F of X plus V of X, which will give us 4,000 plus 2X. Now with the same example, we want to also define a function A of X that represents the average cost of producing X bulbs. So at the average cost per bulb sold is going to be the total cost for everybody, for everything, right? Divided by how many we sell. So we found that our total cost before was that 4,000 plus 2X, and we want to divide that total cost by X, or the number that we sell. To do that, we're going to do C divided by N of X, which we're just going to put that total cost divided by X and get our solution. Now we've done some pretty simple arithmetic so far, and we're going to introduce a new concept now called the composition of functions. Here we compose new functions from existing functions, okay? I know that the image is blurry. I apologize about that. I must have snipped it small. But basically, you're going to have an input, whatever is your function, one function is the output of one function becomes the input of the other function, okay? So you can serve one input, one function will serve as the input of another function. Oh my goodness, my tongue got tied there. Let's look at some examples to make that very strange idea make sense. So the composition function of f of g is denoted as f composed on g, that little circle means composed with, and it is defined as f composed with g of x equals f of g of x. So when you see that f little circle g, that's f of g of x. Here, you're simply going to plug whatever g of x is into your f of x. So let's look at an example. Let's say that we have f of x equals 2x minus 3 and g of x equals x squared plus 1. If we want to find f of g of x, we are simply going to plug g of x into f of x. So anywhere that we see an x in f of x, we are going to put x squared plus 1 because that is g of x. So that means that right here where this x is, we're going to plug x squared plus 1. So we're going to get 2 times x squared plus 1 minus 3. If we simplify that out, distribute the 2, we get 2x squared plus 2 and then minus 3. Combine those two constants at the end, and we get our final answer of 2x squared minus 1. Take a few moments, make sure you can pause this, do whatever you need. Make sure that you can replicate this answer, because again, you're going to see things like this on your quiz, homework, and test. Okay, so let's do another example. We're going to use the same f of x and the same g of x, but now instead of finding f of g of x, we're going to reverse it and find g of f of x. Take a few moments and pause and see if you can get the answer here. Remember, f or g of f of x is going to be anywhere that you see an x in g, you're going to plug the entirety of f of x in. So to get our solution, anywhere we see the x, which is right here in g, we're going to plug 2x minus 3 in. So that means we're going to have 2x minus 3 squared plus 1. Now again, be careful with your algebra here. Make sure that you square this carefully. You're going to get 4x squared minus 12x plus 9 plus that 1 is still sitting out here. Combine those like terms and you get your final answer of 4x squared minus 12x plus 10. Notice that order matters. F of g of x and g of f of x are not the same thing. Let's do one more example. Now you're going to find f of x. So anywhere that you see an x in f of x, you're going to plug the original f of x in. Pause here and make sure you can get an answer and then move on for the solution. So to get f of x, we're going to plug f of x, so 2x minus 3 in where this x is. So we'll get 2 times 2x minus 3 minus 3. And just doing some simple algebra, we'll simplify that down to 4x minus 9. If any of you are used to programming or anything like this, you can see how this would quickly become an iterative process and could lead to some interesting mathematical results. So that is actually it for this section. A lot of it was simple, so hopefully it was a nice breath of fresh air. You'll definitely want to practice with those compositions though, and remember, be very, very careful with your algebra. So basically all we did here was create new functions from existing functions. We used basic arithmetic on the original functions, and we used composition, which is probably a new concept. You'll want to practice, practice, practice. As always, use all the resources available to you. Use the Math Center, use all those resources in Blackboard, visit me during office hours, send me an email, whatever we need to do, and make sure that you are staying strong for success in the course. As always, thanks for tuning in, and I hope to see you next time.